This tutorial is one of many instructional videos presented by the Olympus Industrial Equipment Group. This tutorial video will provide you with detailed instructions for setup and operation of count and measure for object detection and classification within the Olympus Stream software. In this tutorial, we will cover how to set up count and measure on both grayscale and color images. We will cover how to define different classes and how to set up multiple phases for classification of objects. Once we have relevant data, we will go through filtering functions to sort only the required objects and how to export this data to a workbook to use later within reports. To begin, we will need to have both the Count and Measure tool window and Count and Measure Results tool window open. We can begin with an automatic threshold by selecting it using the drop-down menu. Within this drop-down menu, we have our different selections of threshold methods. Since this is a monochrome image, we have only the selection of automatic, manual, or adaptive threshold. To begin, we will select automatic threshold. The automatic threshold window will then open. The main selection in this window is the background type. Choosing a bright background will allow the software to set automatically to thresholds on darker peaks. Selecting dark background will set the software to automatically threshold on brighter peaks. Or you can allow the software to automatically select the background as well, and in most samples this option will be best. To start, we will select the background as dark. This way the detected threshold will be on the large U-shaped material. We want to perform this selection first so we can easily define our region of interest as the large U-shaped area. The other method of defining the region of area would be to manually trace around the edges defining the border. This method is faster and allows the software to automatically detect the edges based on threshold. Now we click Count and Measure. Now we can see the software detected one large object. Select the Detected Objects arrow button so we can select the large detected object by simply clicking on it. Now that we have the area of interest selected, we simply right-click to bring up our drop-down selection menu. In this window, we can select Create ROIs from selected objects. Now we can see the definition of ROI 1 or Region of Interest 1 on the selected area. Next, we will select the drop-down menu for Count and Measure. From the drop-down menu, we will select Count and Measure on ROI to activate this option for use. Now we need to change our threshold definition to detect the dark objects within the large U-shaped sample. Do this by selecting Automatic Threshold. We will now select Bright Background to change the threshold to detect dark peaks. Now we can simply click Count and Measure on ROI button within this window. We now see only the dark objects within the region of interest have been detected. We can select single objects to show their measurement details in the results window. Conversely, we can directly select an object from the list and the software will highlight it within the image. When there are objects that are touching, the software will detect them as one, but if they should be separate objects, we can simply split them using the Auto Split function. First, we have to select the object or multiple objects to highlight them. After the selection has been made, we simply right-click on the object to bring up the Selection drop-down menu. We can select Auto Split Selected Objects from this menu to run it. Now we can select the individual split objects by clicking on them. If the software is unable to split the object due to it having too large of a connection area, you would have to perform a manual particle split by drawing a line using the Selection button. Now let's select Object Filter within the Count and Measure Results tool window. Within this window, we can apply filter ranges to filter out objects by any of our selected measurement values. In this case, we can select to filter by area size to remove objects that are smaller than a certain size. To accomplish this, we simply select the minimum value button. Now we select the smallest object we want to be included in our measurement values, defining the minimum value. We can see that a minimum selection line was generated on our histogram. We can now select and drag this bar to change our minimum value based on area in millimeters squared. If we scroll through the measurement list, we can see all of our selected measurement values, each of which we can set filter ranges for in this window. Now we can select ROI measurements to display the results for our selected region of interest. Within this window, it will display our selected measurement values in total sums for all objects selected in our region of interest area. It also provides the percent area fraction within the region of interest. This is the total percentage of area covered by our detected objects to the entire area of the region of interest. Now we can select ROI histogram to display the values graphically. Within a new image and object particles, we can start count and measure by selecting the automatic threshold button. The automatic threshold function easily detects all of our dark objects. Now select count and measure button. To modify the detection values, the easiest way is to select the drop-down button next to the count and measure button. In the drop-down window, we will want to select detection options. Within this window, we can define multiple detection parameters. The pixel connectivity defines how the software will detect objects that share border pixels. When you have a definition of more pixels to connect objects, it will help to separate objects. If too much separation is occurring, we could change this value to the lower 4 pixels. We can also select to detect objects within the frame or a predefined region of interest. The software has the ability to truncate or exclude objects that run outside the frame, or to truncate, exclude, or include objects within the predefined region of interest. There is a minimum object size filter to eliminate small noise pixels. The default is 10 pixel. If there are objects with void or open areas within them, the software can be set to fill holes by selecting it here. If you have already performed count and measure on an image, you can select to Get from Active Image to select all of the parameters used on that image, then allowing you to capture new images and perform count and measure on them using the exact same detection parameters from the previous image. Once we make our changes, click the OK button to exit. Under the drop-down for count and measure, we can also select to define the classification options by selecting it. By default, the software sets the classification as phase. Phase will detect objects as the percentage they total in area compared to either the full frame or a predefined region of interest. We can also create any custom 1 or 2 parameter classification. We will go through what a 2 parameter classification looks like in setup and how it's applied. First, we will select the 2 parameter classification that was already set up. The star button would be used to create a new 1 or 2 parameter classification. Now we can define this preset classification by selecting the Define Classification button at the top. In this 2 parameter classification, we define objects in classes by area and then shape factor. Shape factor is a determination of how round a detected object is based on 1 being perfectly round and less than 1 being less round. In this classification, we have 3 classes. The first class is set to sort objects of 0 to 1500 micrometers squared area and are of any shape, so small objects of any shape. The second class is set to sort objects of 1500 to 63,226.76 micrometers squared area and 0.19 to 0.71 shape factor, so medium to large size objects that are not so round. The third class is set to sort objects of 15,171.24 to 55,653.62 micrometers squared area and 0.71 to 0.88 shape factor, so large size objects that are mostly round. As we can see, the color of the classes is applied to the objects in the image, allowing us to distinguish the desired classes based on our settings. We can hit OK to close the window. Now we can use the Select Detected Objects arrow to click on Defined Objects. We can see that one of the objects detected is in the wrong class, most likely due to it being connected as one particle. We can select this object by clicking on it. We can continue to select other linked objects by holding the Control key and clicking on them. Now that we have the object selected that we would like to have split, we simply right-click on the last object selected to bring up a drop-down menu. In the drop-down menu, we will select Auto Split Objects. This has now split the objects selected and placed them into the correct classification, also adjusting the object count and showing the new individual object measurements in our list. We can also now select any objects that may have defects to remove them from our results. After making the selection, we just right-click to bring up the drop-down options menu again. Now select Delete Selected Objects to remove the object that's defective from the results overall. We can now select Class Measurements to display those results. Within Class Measurements, we can see the selected measurement value for each individual class, such as the total sum area in micrometers squared or the object count in each class. Now we can select Class Histogram to view it. Within this window, we can display several histograms of our classes. To change, simply click on the drop-down selection. We can see all the different histogram selections we can choose from to display. If we select Area Fraction ROI, it will then display the histogram of each class area by percent fraction within the region of interest. We can now return to Object Measurements. We can double-click on Object Class Color column to sort the list of objects by their class. We can scroll through the object measurement list and see the sorted classes by color. We can simply create a workbook of all the object measurement results by selecting the Export to Workbook icon at the top of the tool window. This now places the entire list of objects with the applied class color sort we defined in our internal workbook. The workbook can then be exported to Excel or used to quickly save into our database or used in the Stream Report Generator. When performing count and measure on color images, there is a need to detect by individual color range for objects. As in the example image, we have 4 color ranges: red, green, blue, and yellow. If we simply select Automatic Threshold, it will try to detect the average range of colors. As we can see, the Automatic Threshold was able to detect the green and most of the blue, but misses the detection of the red and yellow objects. We can click Cancel to exit the Automatic Threshold. To define these complex color objects, we will want to choose the drop-down menu for thresholds. The easiest way to define color ranges is to use HSV, or Hue and Saturation values. We will select Manual HSV Threshold from the drop-down list. In this window, we can see 3 ranges of selection: hue, saturation, and intensity value. At the top, we can also see phases. This is where we will tell the software how many different phases or color ranges we would like to detect. We will select the star icon to add a new phase. We will keep selecting new phase until we have all four for each color range in our example image. We can see by scrolling through the list we have four phases and each match to a color in our sample image. The color matching is a coincidence, and each color can be changed in the list. The color will match to the overlying threshold. To begin, we will select the first phase, and since its color is red, we will use this phase for our red range. After selecting the phase, we will then select the new threshold dropper icon. We now are able to use this dropper icon to select the color range directly on our sample image. We will begin by clicking on the red color. Now the software automatically switches to the add-on dropper icon, which will allow us to keep holding our left-click mouse button and drag the dropper over more areas of red color range to select all the phases of red. We can even stop holding the left mouse button and move to another area to continue selecting the red color range. Once we have the entire range of red color phase selected to now see the entire red area covered with the red threshold, we can right-click to end the add-on dropper selection. Now we need to select the second phase, which is green. Using the same method, we will select New Threshold Dropper icon. Select the green color range. Continue to hold the left mouse click and move over the rest of the color range to highlight. Move to other areas to continue this selection. We now right-click to complete the dropper selection. Continuing, we will select Phase 3. We will select the new threshold dropper. We will select the yellow phase. Continue moving the dropper over the phase area to highlight it all. Right-click to complete. We will select our last phase for blue. One last time, we will select the new threshold dropper icon. We will select the blue color range. Continue marking the color range with the dropper tool. Right-click to complete. We can now see that the software has marked 4 individual phases for each of our color ranges defined. If we select Hue from the channels, we can then see the individual color range selections in the histogram below. If we were not to use the dropper tools, we would have had to manually select each phase of hue and define the individual intensity and saturation values, which is quite time-consuming. Now we can simply select Count and Measure. We can now see each of the colored dots have been detected and counted. We can select Class Histogram to view each of our phases. The first window shows us each phase by their total area fraction for the sample. If we select the drop-down menu, we have more viewing options. We can select Object Count to get a quick count of each color phase. As we can see from the example image, we have 5 red, 3 green, 2 yellow, and 3 blue. This is a quick way to show count of color objects. To continue to other images with the same color range, we can select the next example image at the top. Now that we have already set the criteria for our color ranges, we can simply select the manual HSV threshold button. We can see quickly that all the color ranges have been detected and properly thresholded. Now we simply select Count and Measure. We now see in our class histogram the total counts of each phase for our new example image. Now we can select Object Filter to demonstrate how to filter out objects by certain values. We can expand the tool window to help view all the measurement values to use for filtering. Now we will select Object Class ID. This will display the histogram of our 4 classes or phases detected. If we want to filter by a lower value, we can select Minimum Value button at the top. Now select the object of our minimum value to filter by. This will create a line adjuster in the histogram tool window that we can then drag to any point we wish to adjust the minimum filter value. If we move the slider to 1.5, which is between class or phase 1 and 2, we will see that the filter has removed the objects in class or phase number 1. We can also see the values in the min/max columns. This is where we can manually enter values. We can double-click on the max value box to make changes to it. By adjusting the value for max to 3.5, we will see the software filter out the 4th class or phase. We can also see the object count has changed from our total of 11 to 5. To clear a filter range, we can simply select the Clear Maximum or Minimum Value icon at the top. In this instructional video, we have covered count and measure within the Olympus Stream image analysis software. We hope this video has been beneficial, and we invite you to contact us directly with any questions.